Hi, we are from Group 14. This is our title, Design and Implementation of a PLC-based Industrial Control System for Quality and Efficiency Optimization in the Food Beverage Industry. My name is Tujunyi. My next member is NURUL MUSLIHAH, Muhammad NAZHAN, Muhammad Firdaus, and Muhammad AQIL. Introduction. Automation is a key element of the food and beverage industry by automating tasks and reducing operator intervention through the use of programmable controller and software like CX Programmer and TIA Portal. Programmable logic controller provide the advantages of higher efficiency, more accuracy, and a better product quality, but at a lower cost and human errors. Common applications include high accuracy automated conveyor displacement, water filling, and capping by employing sensors and timers to automate and synchronize. Especially the automated bottling system is of the prime interest in order to highly ensure the quality of the product and its minimal waste generation. The purpose of this work is the creation of the bottle processing automation PLC-based system, which it will lead to a further improvement of the production yield and the robustness in food and beverage industrial sector.
Now I'm going to discuss about our objective for our system, which is design and implementation of a PLC-based industrial control system for quality and efficiency optimization in the food and beverage industry. Okay, for the first, our objective, which is improving efficiency. Optimize production process, reducing downtime, and ensuring efficient utilization of resources such as raw materials, energy, and labor. Second objective, which is cost reduction. Minimize operational costs by improving process reliability, reducing waste, and enhancing resources management. And for the last objective, which is quality control. Ensure consistent product quality by integrating real-time monitoring, precise control of parameters such as temperature, pressure, timing, and immediate feedback for corrective action. For this part, which is circuit design. Firstly, we press start button to start our system to move the conveyor, and then the sensor will detect the bottle and the timer will trigger. After 2 seconds, the conveyor will stop and the water will pump for the 5 seconds. After finish this process, the conveyor will move and emergency button to stop our system.
For the component description, first we have the PLC. PLC is the brain of the system, processing sensor input and sending command to actuator for seamless operation. Second, the bottle sensor is to detect the presence of the bottle at the filling station and signal the PLC to stop the conveyor for accurate filling. Third, the conveyor. It's to transport bottle to the filling station. Its movement is controlled by the PLC for precise positioning. 4. The push button. It allows operator to manually start or stop the system for setup or operational control. 5. Timers. Timers is to control task duration like stopping the conveyor and running the filling pump, ensuring consistent operation. 6. The emergency stop button is to stop all operation instantly during fault, ensuring safety for both equipment and operators. 7. The actuator. It's like valve and motor perform a physical action such as stopping the conveyor and opening the filling valve controlled by the PLC.
Application. So how application works? First, automation. The PLC controls things like moving bottles, filling them and labeling them so everything happens in the right order. Real-time monitoring. It constantly checks things like the amount of liquid in bottles and temperature, making adjustments as needed to keep quality consistent. Next, error detection. If something goes wrong, like a bottle getting overfilled, the system catches it and fixes the problem right away, reducing mistake and downtime. Data tracking. The system track of production data so operator can see how things are going and make improvements. Energy saving. The PLC helps save energy by turning machine off when they're not needed, keeping costs down. Lastly, maintenance alert. The system watches equipment for any sign of wear and alerts operators when maintenance is needed, preventing sudden breakdown. So, what is the benefit of our application? It can keep product quality consistent, speed up production, and reducing waste on energy costs. Next is result in 3D. After we push the start button, the conveyor starts to move and stop at the bottle sensor, and it fills with water around 5 seconds. After that, it rotates and cycles at the same thing all over again. So, we're using PLC, human cannot waste their energy anymore. So, we can use this in our industry.
So, after all this, we know investigating how the system is used for day-to-day operations and various control parameters of the bottling process such as flow rate, waste, reveals that the PLC-based control system is successfully applicable to improve bottling operation in the food beverage sector. Use of the CX programmer for ladder logic design guarantees accurate timing of conveyor motion, bottle sense, fill and cap. Operational efficiency and safety are further improved by real-time monitoring, sensor integration, and the inclusion of safety features such as emergency stop mechanisms. Virtual testing using factory I/O aids system robustness and facilitates refinement prior to physical deployment. The scalability, adaptability, and cost-effectiveness of the project are shown, resulting in high productivity, low waste, and constant quality control thus providing a sustainable and future-proof means of automation. Thank you.